Hello and welcome to one of the hopefully many Pipeline Explorer demos. Pipeline Explorer is a GUI tool that is bundled with GVK. GVK, as you can see up here, is a library of Vulkan utilities that helps with tool development, although it has other use cases and can be very powerful. This is the GVK repository. It's open sourced. You can get to it at github.com/intel/gvk and feel free to contribute. It's provided in source, so to get the binaries, you'll want to clone it and then build it. Once you built this repository, you'll find the gvk-pipeline-explorer folder, and you can get to the binaries from there. So let's run Pipeline Explorer. All right, so here we have a couple windows. I'm going to minimize metrics charts. We'll get to that later. But the main window I want to highlight first is the Workspace window at the bottom left. A couple things I'd like to highlight. First is the Workspace. This is a directory that Pipeline Explorer uses. Its default is in your documents, a folder in your documents. However, you can change that by deselecting the checkbox and then typing in whatever workspace you'd like to use. So this down here is the launch area. There's a launch button and there's the launch directory with the executable that you would like to launch. I'm using the Sasha Willems Vulkan Infinite Procedural Terrain workload, which I'll launch right now. And this will get the Pipeline Explorer layer loaded into it. Pipeline Explorer works as a real-time performance analysis tool. So you will run your applications alongside it in this kind of split screen format, as you can see right here. It's loaded in as a layer, so that allows a lot of control over this Vulkan application and how it works with the GPU, which is perfect for performance analysis. So the second window I'd like to highlight is the pipelines window right here. We're going to refresh the active pipelines, which will populate this table with all the pipelines that the layer can see at the time we click the button. So here we have at least 10 pipelines, maybe more. And right now they're sorted by time per frame. This is really useful to see what pipelines are taking the most time per frame. You can also sort by executions per frame. And this is the UUID, if you were interested in the pipelines handle. So a way to understand what pipeline is rendering what pixels to your application is to use the highlight experiment. This is a shader experiment. It edits the fragment shader that the application is sending to the GPU, and it changes the color to be whatever color you want. You can change the color here by clicking on this color, but for now, I'm just going to highlight this first pipeline. That takes the least amount of time, and it makes sense. It is a IM GUI element up at the top. Let's look at the pipeline that takes the most time. This is the grass, it appears. Yeah, it's really a beautiful sample. I'll move it around and explore a little bit. Yeah, there we go. There's a good scenic spot. All right, so yeah, we got some reflections. So the second pipeline that takes the most time is the shoreline right here. And if I turn off the experiment, you can see a little bit here. I'll go a little closer. You can see that the grass is being reflected, and that is, yeah, right here. You can see it right here in the middle of the screen, that the grass is being reflected, and that is what this second longest pipeline does per frame. The third pipeline is the land texture. The fourth pipeline is the water plane, and we can keep going. The shadows for the trees, and yeah, I'm not going to go through all of them, but this helps you see what pipeline corresponds to what on the rendered application. So now we're going to go with the grass reflection, and we're going to go up to the selected pipeline window. Here we have a bunch of different options, but I'm going to focus on the decompile button for right now. So here in the selected pipeline window and in the metrics window, these two windows are relative to the selected pipeline context. So if you change whatever pipeline selected in the table, you'll change the context wherein these two windows operate. You can see the UUID of this pipeline. When we go back to the grass reflections pipeline, the UUID changes. We're going to focus on the grass reflections pipeline. So here we're going to click decompile. This will save pipeline state information as well as the shaders into the workspace. You can view those files in the actual workspace, in your documents folder or wherever you set the workspace to be. However, we can also view these files within Pipeline Explorer. So these are the pipeline's create infos for the descriptor set layouts, the pipeline layout create info, graphics pipeline create info, and here are the shaders. So we can edit the vertex and the fragment shader and then recompile those, and we can see how that edited shader changes metrics, how it changes the application in real time. It's pretty cool. So let's try to edit the fragment shader here. All right, here is the GLSL shader. Let's take a look at what's going on in here. We have texture projection, shadow mapping, apply fog, cool stuff. So we're just gonna strip this down for this demonstration reasons to just be a static color. Let's go with 0.4, 0.5. Let's make the alpha 0. And these will probably be compiled out, but I'll delete them anyway. So it's totally stripped down now. Let's see what this does for the performance. Now, you could have edited this in your text editor of choosing as well, but however you decide to edit it and you save it, then you will recompile with this button, and this will activate the shader experiment. So as you can see now, if you look at that area where the grass reflection used to be, it is now gone. All right. So now we're going to go to the metrics window, refresh available metrics. This will bring up the metrics we have available. We have a pipeline statistics metrics we can query. Then we also have Vulkan performance query extension that if your driver supports this extension, we can grab metrics from that as well. So let's do that for now. I'm going to just take, we'll take two metrics. Let's take the transaction output and GPU time. And if you're ever wondering what one of these metrics does, you can hover over it. It'll show a tooltip that gives a description. So before I click query metrics, this auto query checkbox, if this is on, it will query metrics every so often, pretty quickly actually. If it's off, then if you click query metrics, then it will query it, and then if you want to query it again, then you click it again. I'm going to leave it on for now because I think that gives a nice demonstration of what's going on. All right, so now we see very quickly updating metrics, so that's great. Let's see what happens if we turn the shader experiment off, if we take it back to its normal form. Okay, it looks like it went down. An easy way to understand what's going on is to turn the metrics charts window on, and this will visualize the data. So yeah, as you can see, GPU time has went down. If we turn this back on, it goes back up. That is very interesting. Wild. Yeah, we'd expect GPU time to go down if since we stripped it down just to out frag color being static. So let's try something. Let's change the alpha to, let's say, 1. We'll save, recompile. All right, you can see that we definitely, can see the out frag color now. It's very visible. However, the GPU time has gone down by a lot, even less than it was originally with the original fragment shader, it looks like. Let's confirm this by turning the experiment off. And yep, we can see on our graph that the GPU time is now higher. And if we turn this back on, it is lower. And that is a difference of, looks like we're at 2 million about normally. And if we turn this on, we're at 360,000. So that's a pretty big difference. So thinking about performance analysis, there may be a code path when alpha is 0. As we noticed, when alpha is 0, the GPU time goes up. There might be a code path with lots of overhead that this application goes down when the outfrag color alpha is low, which results in the higher GPU time. If the grass reflection frag shader code never outputs a low alpha color, then this scenario wouldn't occur. But it's a path we could explore if we're thinking that might be something to look at. When the alpha color is at 1, when it's full, we can see that the GPU time drops significantly, which is to be expected as the grass reflection is the second longest pipeline. Although we ruined the fragment shader here for demonstration purposes, as you can see. If we've instead focused on optimizing it, it would probably make a good performance impact on the application. So these are the kinds of findings that we can make using the Pipeline Explorer. I want to thank Sasha Willems for making this great sample. It's one of his pet projects, not like his core Vulkan samples, so I'm really grateful that he released it so we could all enjoy it. It's the infinite procedurally generated terrain sample. If you want to look it up, I'll put the GitHub link online. So yeah. One more thing I want to show real quick. If you go, I'm going to maximize this now. If you go to the Windows tab and click API Call Explorer, this will take whatever frame is running in the application at the time that refresh API calls is pressed, and it will show all the API calls in that frame. This can be very useful. You can see the parameters for each API call, and we plan to add more features to this API Call Explorer and make it more useful over time. So that's all I wanted to show here for today. Thank you for listening, and I hope you guys all have a great day.